Alright, in brief, let's just see if we can schematically represent the hydrogen bonding in water. So you have your central O atom. It's bonded to two hydrogens. We know now that it's bent. We know now that we've got an area of positivity around here. It's going to be positive. An area of positivity around here. And a strong area of negativity around this oxygen. Why? The oxygen is extremely electronegative. It has high electron pulling power. The hydrogen is very weakly electronegative. It has hardly any ability to keep its electron. So though they share, there's an electron here and an electron here, to form the normal covalent bond, we have a highly polar covalent bond such that at any given time, the electrons involved in the bond spend most of their time around the electronegative atom. Likewise for this guy, we have an overall dipole, and around this hydrogen we essentially have a raw nucleus. There's very little electron cloud, electron shell, which is the only source of negativity for these particular hydrogen atoms. What happens is that when another water molecule comes within the vicinity, likewise displaying the same properties, here's a negative area, here's a positive area and a positive area, this negative hydrogen nuclei is so negative that so positive that the very negative area on this oxygen atom is attracted to this neighboring hydrogen atom with a strength of about 1/10 the normal strength of a normal covalent bond. So it's incredibly strong. It's almost like the H2O molecules have now formed the super water molecule, but this is happening for billions and billions and billions and trillions of water molecules at the same time in a sample of liquid water. This presence of the hydrogen bond explains the unusually high melting and boiling point for water, its strange level of viscosity, the surface tension it displays, the high heat capacity that it has, and we will also see the anomalous form of its ice, its solid form, as opposed to the liquid form of water and the densities therein. So the hydrogen bond can only form with fluorine, oxygen, or nitrogen atoms. Why? Because only these three are highly electronegative that have the power to pretty much pull the whole electron off the hydrogen to themselves, thereby exposing the hydrogen nucleus, the positive area, for an affinity to another neighboring electronegative polar molecule.